Hello, students, MCs, math connections out of 12, 4, 3, 5, 7, 10, and then a couple little pairs. Let's take a look at these as we go. So 3, 5, and 7. I give you two isosceles triangle with a non-base angle of 40 degrees. Are they similar? Okay. Make sure you justify your answer. Everything has to have justification. And again, if you say it's similar, I need something like a side angle side, or side, 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 or angle, angle, something like that, okay? Number 5, suppose TRI is similar to RIT. What do you know about TRI? Ooh. Now, again, for some of you, you might look at this and say, where's the other triangle? They are giving you everything you need because what they're saying is that TRI is similar to RIT. So it's basically, it's the same shape. And they're telling you how things match up. Remember, in a shape that's similar, the angles have to be congruent. So angle T has to be congruent to angle R. So T has to be congruent to R. And then angle R has to be congruent to angle I. Ooh, that tells me something. Oh, that tells me something, doesn't it? What kind of a triangle do I have? I'm going to leave it there because I think it's kind of cool for you to see it. Question 7. I did a separate video of this as a student kind of wrote in, but again, if you follow the steps and create the proportions, you might be able to prove something really cool about a right triangle. That is, a squared plus b squared has to equal c squared. Okay. Not only that, there is a built-in x to h to y geometric sequence. It is also used to create a geometric spiral. As you connect these, you just say, okay, from here to here, I create kind of a curve that branches out to h, branches out to y, and keeps branching out as you do it. And you get this beautiful spiral. Some people have seen in nature shells of different shellfish, how they have these kind of, if you kind of cut them down the middle, you'll see these beautiful spirals in their shells. Okay, let's see here. So 3, 5, 7, and then I said 10, 13, and 14. So 10, how are side, 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 and side angle side similar like this for congruent triangles? How are they different? So I guess the question is, again, if you were a student taking this class and you saw side, side, side being used for similarity and for congruence, you might think they are the same. Now, how are these alike and how are they different? I wish they worded that a little bit better, right? What is similar about them? What is different about them? Okay. Think back to the difference between similarity and congruence. That'll be a big one for you. And then let's see here, 13, 14, and 17 and 19. So 13 to 14, this is the lamp post. Perfect. But now it says, how long would her shadow be if she approached 8 inches closer to the lamppost? So find a nice, my shadow cast is 5 feet long. If I move 8 feet closer to the lamppost, what's going to happen? Okay, because once again, the ratios would be the same. 14, this is going to be something we use in chapter 13 when we talk about the perimeters of similar triangles or the perimeters of triangles or other shapes that are similar. It doesn't have to be a triangle. And basically, if you have a triangle like ABC, nope. Let's see here. This would be A, length C, and length E. I'm just looking at the top here because they say those are the same. And up here, I have a different triangle, and it has lengths B, D, and F. And we say that these sides are in ratio to each other. That means that B is equal to A times R, and D is equal to C times R, and F is equal to E times R. So I made a separate video showing this, and I thought about it, and I was like, you know what, this is actually, I like this better if we show that ratio, because then you can see that this one on top is AR plus CR plus ER, and when you factor the ratio out, you get A plus C plus E, which is the perimeter of the other one. So it's in the exact same ratio as the sides. And we'll see in chapter 13 what happens to the area when you scale something up. We'll get to see how that works. Okay. Very cool there. Okay, 13, 14, and 17 through 19. 17. Okay. Arturo writes ABC is similar to TRI. Betty writes that ABC is similar to RIT. Who is correct? This is all about seeing which ones have to be congruent, which angles have to be congruent. Match them up and see whether it's Betty or Arturo. 17, 18 up here. Malika says if each right angle has an acute angle with the same measure, each right triangle has an acute angle with the same measure, the triangles are similar. So again, we're talking about two right triangles, right? So if we have this, and then maybe a bigger one over here, but has a right angle. Each right angle has an acute angle with the same measure. So if this angle matched this angle, is the triangle similar? I think if I was a teacher for Malika, it sounds like she's trying to come up with a way to do it where in her mind, it's not really angle, angle. It's just angle. So if you know it's a right triangle, then you don't have to even check that. You know that's for free. So you just need one angle, which is kind of cool. That'd be a really cool property. 19, the student claims that if one angle in an isosceles triangle is congruent to an angle in another isosceles triangle, the triangles are similar. How do you respond? Interesting. Boy, oh boy, oh boy. That's a good question right there. I wonder, is it possible to have an isosceles triangle where that's not? What a great always, sometimes, never question. That is fantastic right there. All right. 21 and 22 are the last ones down here. The student argues because these sides are divided proportionally, that therefore one side is the 2 to 4, the other is divided into 3 to 6. I want you to use your critical thinking skills here. Are those triangles similar? One of them is in a 2 to 4, the other is in a 3 to 6. We have the theorem that says if they're divided into proportion, therefore they become similar. Is that going to hold here? Is that going to work here? I'm not sure. And lastly, the student asks whether there is an angle side angle similarity condition for triangles. You got to tell me. What do you think? What if a student said these triangles are similar by angle side angle? What do they mean, and does it actually work? All right. As the MCs for the last section in chapter 12 in the book, there is one additional piece. They used to have it published in the book. Now it's in an online module. You can find that online module by clicking on any of the pieces for our course. Let's see here in the homework set. You can see it here. It's module H. Click and boom, there it is. And that's the one that we'll be doing next. Module H, using a geometry drawing utility called GeoGebra. So we're going to go over that in our next videos and in class next week. All right. Hope to see you then. Off you go.